Hello friends, in this video I will be creating a layer 4 load balancer right from scratch by using Java. First I will create an HTTP web service that I will deploy on 2 remote servers, and then I will create a layer 4 load balancer that I will also deploy on some remote server, and that will accept a TCP connection from the client and then pick one of the remote servers from the web service and make a request to it, and whatever the response from the web service, it will respond back to the clients. So without any further ado, let's get started. Let's go to start.io. Let's select Java Maven 2.7.13, and artifact name as demo is fine, and Java 8. For dependency we'll use Spring Web, and let's generate. Let's open this in a IntelliJ. Now let's create a simple HTTP endpoint. So for that, let's go to source. Then let's create a controller. Controller dot hello controller. Annotate it with the REST controller. And let's create a get mapping. Index will be, the URI will be hello, and let's name it as, we can name it anything, Spring get hello, and let's the return type, let's return some message. Let's return the IP address in the response so that we know that the response is from which host. Okay, so to get the IP address, I have created a video on my YouTube channel. You can copy the same code. I'm gonna copy the same code. So with this you can get your public IP address. And let's return. Okay, so return is hello Pushkar. The response is from IP at time local date time dot now. Okay, so now let's run this and see like how this responds in my local. Okay, so as you can see, the service is up. So now let's open the Chrome, and let's see the output. So now let's go to localhost 8080, endpoint is hello. So the response is hello Pushkar. The response is from IP 104.232.116.173. This is my public IP, and the current time is this one. And to check my current IP, let's go on Google and say what is my IP address. You can see my IP address is 104.232.116.173, and this is same as this. Okay, so our backend service is now ready. You can also make a curl request to this endpoint. So let's copy this, and let's see here curl you can see the response is hello Pushkar. The response is from IP this, and at time this one. So right now the service is deployed, is on my local machine, that is my desktop, but going forward I will deploy it on the remote servers, and our load balancer will be in front of our backend services. So now let's create a Java project for load balancer. For that, let's go to IntelliJ and create a new project. For that, let's go to the folder workspace and name it as load balancer. Archetype is a quick start, and yeah, that's pretty much. Okay, so let's change the class name to load balancer. So refactor, rename load balancer, and let's have the first line as load balancer started, and let's convert this into an executable file. Okay, basically an executable project. So for that, let's add some Maven plugin. So this is the Maven plugin that will make this project it into an executable jar. So this is a standard code that will convert this package, this project, into an executable jar, and this is the main class that will be executed once you run the project. Okay, so this is the class name, arg.example.load balancer. So now let's create a server socket, and for that let's go server socket, new server socket, and let our load balancer be at port 8081. Okay, 80. Started at port 8081. Well, let's change this to an integer. So now let's create a while loop so that this load balancer can accept as many requests as possible and then serve it, okay, by using the backend host, okay, remote host. So for that, let's take this as a while loop, and the very first thing it will do is it will wait for a client. Okay, so whenever a client connect to this server, a first TCP connection gets created. Okay, so for that, let's say socket is equals to server socket dot accept. So this server socket dot accept wait until a client make a request to this load balancer. So whenever a client make a request to this load balancer, a TCP handshake, a three-way handshake takes place and a connection is established. Okay, so let's say TCP connection establish with client, and let's have some client details. So socket dot toString. Okay, so this toString will return the address of the client, the port of the client, okay, and the port of the client, and also the port of this server. Okay, so now let's create a thread to handle each TCP connection. So for each client connection, we'll create a thread that will handle the client request. Okay, and that thread will connect with the backend host, okay, and get the response, and then forward that response to the client. So now let's create a thread that can handle the client socket. So for that, let's create a class. Let's call it client socket thread. Okay, client socket handler. implements runnable. It will have a private field called socket. Okay, or let's call it, you can say, client socket. So the constructor of this will accept a socket, client socket. So public client socket handler, final socket this dot client socket is equals to socket. So now let's have our, so now what we will do is this socket will create a connection with the client. Okay, so it will accept the data from the client and forward that information to the backend service. Okay, and whatever it gets from the backend service, it will forward it to the client. Okay, so now let's first get the input stream from the client so that this load balancer can get the data that is client is sending. Okay, so for that, let's inside our try, let's create input stream. Let's call it client to load balancer input stream. Let's call it client socket dot get stream. Similarly, there will be an output stream. Call it load balancer to client output stream, client socket dot get output stream. And let's have a backend connection. So for that, we need to select a backend host. So let's create a actual load balancer algorithm that will have a list of the backend host and gives one host at a time. Okay, to which the load balancer forward the request. So for that, let's create a separate class. Let's call it utils dot backend servers, and it will have a private list of IPs that will be in string format. And let's say it will be new servers array list. In static, let's add some servers in this. Let's call it IP1. Let's make it static. I will add the local IP of the servers later here. So this is server 2. Okay, and let's take one count variable. Public string get remote host, or let's say get host Okay, so it will simply return servers, and let's say the count is let's select the server. So string host is equals to count modulus servers dot size, and to make it round robin, let's update the count plus plus. Okay, and return the host ID. So how this work is in first when the program runs the first time, when the get host is called first time, it will simply go to the count is 0, so 0 modulus the size is 0, so it will return the first host, that is IP1. And in the second time the count is now 1, and then 1 modulus the size of 2, the size of servers, which is 2, the 1 modulus 2 is 1, so in that case it will return IP2. So basically it is now returning the IP in the round robin fashion: IP1, IP2, IP1, IP2. If there are 3 servers, then IP1, IP2, IP3, IP1, IP2, IP3. Okay, so now the backend servers is done. Let's make it static too. Okay, so in the client host, not host, in the client socket handler, so after getting the stream, now we need the backend host. Okay, so let's call this string backend host. So for that, let's call it backend servers dot get host, host selected for host selected to handle this request. Let's call it backend host. Okay, so now let's create our socket request, basically a TCP connection to the backend server. Okay, so now we need socket. Okay, so this will take new socket and this backend host, and we know the port of this, the port is 8080. Okay, this will be integer. Okay, so now this line will create a TCP connection with the backend servers. Okay, so now let's create an input stream and output stream to the backend server. Okay, so let's input stream load balancer to backend server input stream. Okay, so for that we call it, let's say socket, or let's call it backend socket. Backend socket dot get input stream. Similarly, output stream. So this output stream is basically sending data from the backend server to the load balancer. So let's call this backend server to load balancer output stream. So now we have both the connections has created. Okay, so a connection from client to load balancer and load balancer to the backend server. Okay, so the connection has been created at this point. So now we have both input stream and output stream. Input stream to get the data from client and output stream to send the data to the client from load balancer. Similarly, an input stream to get the data from the load balancer and output stream to send the data to not load balancer to the backend server. So now what we need to do is, whatever the data that is coming from the client, we should pass the data from load balancer to the backend server, and whatever the data that is coming from the backend server to load balancer, pass that data to the client. Okay, so we'll create this to have this functionality. Let's create a thread and that will handle this like on their own. So basically one thread will handle the data coming from the client to the load balancer and pass it to the load balancer to the backend server. Okay, so let's create a thread for that. So thread, let's call it client data handler, new thread. Now let's create public void run method for this thread, and let's include it in a try block and have int data. So whatever the data that comes from the client to the load balancer, pass it to the backend server. So data is equals to dot read not equals to -1, and let's catch the IO exception. So now whatever the data, so this while loop will read the data from the client to load balancer byte by byte. So each byte by byte, the data will come to this thread, and each byte let's send it to the backend server. Okay, so for the backend server we have the output stream called backend server to load balancer. Okay, not load balancer to backend server. Okay, so this is the naming is little wrong. Okay, so this input is, so let's see in like from load balancer behalf, this input stream, okay, is basically for getting the data from the backend server, okay, from the backend server to the load balancer. So let's name it backend server to load balancer input stream. Okay, backend server to load balancer input stream. Okay, and this is like from backend server, and this output stream is for basically sending the data from load balancer to the backend server. So let's say load LB to backend server output stream. Okay, so we have to pass the data to this output stream. So write the data. So basically input stream is to read the data and output stream is to write the data. Okay, so this will basically, this thread basically get all the data byte by byte from the client and now pass it to the backend server byte by byte. Okay, so now we are done with the thread. So now what we do is we'll start this thread dot start. Now similarly we need another thread that will read data byte by byte from the backend server to the load balancer and then pass it to the client. Okay, so now we'll create another thread. Let's call it backend data handler and new thread. Let's copy this entire end-to-end. Okay. And here we will read data from backend, okay, from backend to load balancer input stream. Okay, so let's call it backend server to load balancer input stream, and where we will pass load balancer to client output stream. Okay, which is this one, load balancer to client output stream. Okay, now let's start this thread. So now I think this thread handler now should work. Now let's update the load balancer class. So in the load balancer, so whenever a new socket is created, the client socket handler will handle that socket. So now let's create an instance of that. So for that, let's say handle socket. So this method, and this will be a private method, and this method will create an instance of client socket handler, new client socket with socket, and let's create a thread, client socket handler thread. Okay, let's give this and then start the client socket handler. Okay, so basically now the looks like the entire load balancer code is complete except this IP address. Okay, so here whenever client, so when this setup is up, so whenever a client is trying to connect the load balancer accept the TCP connection and then figure it out one of the two backend service or two remote host. It will pick one of the two remote host and then create our TCP connection to the backend service, okay, backend servers, and whatever the data it gets from the client, it will pass to the server, and the server will process and return a response, and then load balancer return the same response without changing anything to the client. Okay, so now let's do our deployment. Okay, so we'll host the demo web service on couple of IP addresses on couple of hosts, and then add their address in this static block. Okay, and then we'll deploy the load balancer in one of the server. Okay, and then we'll try to access the load balancer through a curl command, and let's see whether the which host is responding. Okay, whether the load balancer is working correctly or not. The algorithm here we have used this round robin, so it will pick one host at a time. So one host, the other host, again one host, the other host. Okay, IP1, IP2, IP1, IP2. Okay, so let's do our deployment. So for that, let's create a deployable artifact of this demo. So this is the demo web service. So let's go and create Maven package, package. So as you can see, the Maven package is complete. So we'll have one target, this demo 0.0.1 snapshot. So this is our deployable or runnable artifact. So we will use this to deploy on our remote servers. Okay, so let me create some remote servers, two remote servers for this demo and one remote server for the load balancer. So before deployment, let me explain you the setup. So here I am. Okay, I'm using my Mac terminal. Okay, and this will interact with one load balancer. The IP address of load balancer is 35.0.0.0 190.101.211, and it will have two remote servers. Okay, this is one remote server and this is another remote server. Okay, and here both remote servers have exposing up an endpoint called hello. Okay, and they are responding the response, okay, whenever a request is made. So this is 1 and this is 2. The public IP of instance 1 is 54.188.156.42, and the public IP of instance 2 is 54.212.197.100, and the private IP of the instance 1 is 172.31.100.239, and the private IP of this is instance 2 is 172.31.110.223. Okay, let's first deploy the backend service on these two remote hosts and then get their local IP address, and then use the local IP address on the load balancer, and after updating the load balancer IP, we'll deploy that load balancer project into the load balancer host, and then we'll call the load balancer IP by using the curl command. Okay, so let's go our deployment. So let's first do the mvn package. I think I have already done this. Yeah, so deployable artifact is already there. Okay, so now let's first ssh into the remote host. Okay, so this is the first host, and then ssh into that. So ssh cloud user, password is, and also ssh into the other one where we'll deploy the web service. Okay, as you can see, both are empty. So now let's send the deployable artifact to this remote host and then run the application. So to send it, I'm using http command. So http target demo, and it sent to cloud user underscore, the first IP is this one, and I will send it as home cloud user, password is. So now you can see it has reached to the first host. Okay, and let's run it. So java jar demo. Okay, so now from our Mac, let's call it the public IP. Okay, I'm showing you the public IP because it is we can access this through public IP as well, but I will use the private IP in load balancer because ideally you should not expose the public IP of your backend servers, because so that they are disconnected from internet and only load balancer can access it. This is because of security reasons. Okay, so if we do a curl command, http, okay, so as you can see, it is showing the response, and see, it was the host is 156.42 and the response is from this. So no matter how many times you call this endpoint, you will get the same response, but except a different time, right? Because response from the same IP, because there is no load balancer in front of it. So now let's deploy the same web service into another host. Okay, this host is different one. Okay, so now let's copy the same command and change the IP address. So now you can see the demo is now here. So now let's run this to java-jar demo. and copy the IP so that let's see whether this is also up or not. Okay, now service is up. So in curl command, okay, now let's change the IP to this second one. Okay, and let's see the response. So the response will also be from the same IP. Okay, as you can see, the response is from this same IP. Now no matter how many times you call this, you will get a response from the same IP, but the response is different because I have added the timestamp. As you can see, the timestamp is always a different one. Okay, so basically the response is actually from this servers. So now let's add these servers behind our load balancer. So our load balancer, for load balancer, ideally we should use the local IP. So let's use the local IP. Now to get the local IP, let's turn down the service and find the local IP. Okay, I already showed you the local IP, right? So the local IP is the first one, 172.31.100.239. So as you can see, the local IP is ifconfig. As you can see, the local IP is 172.31.100.239, and this is the same IP that I showed you on my iPad, that is this one. Okay, 239. So now let's copy this and add this in our load balancer package. Okay, load balancer project. So let's copy this and add it in IP1. Okay, similarly for the second one, let's see ifconfig. This is 110 to 222. Okay, so this is also same as this one, 172.31.110.223. so as you can see, 172.31.110.223. so copy this and add it into the load balancer project. So now our load balancer project have like both the servers. So now let's do a maven run. Okay, maven package, so that let's have the deployable artifact of this load balancer as well. So mvn package. Okay, so now we have the deployable artifact of this load balancer as well. As you can see, the load balancer -1.0 snapshot.jar. This is the deployable artifact. So now let's deploy this load balancer into the IP address of this one. Okay, this is also a remote host, 35.90.101.211. Okay, so now let's do a cp command. So let's first SSH into it. Okay, so let's say this fourth quadrant is our load balancer. So let's first SSH into this one. Okay, so SSH cloud user. As you can see, this host is also empty. So now let's send the load balancer into the that host. So for that also let's use the SCP command. So HTTP target load balancer cloud user @public IP. So as you can see, the load balancer deployable artifact is also present, is also reached to the this host, remote host. Okay, so let's run this. So before running, let's first make sure that our backend servers are up. So for that, let's deploy them. So as you can see, both the servers are up. So now let's run the load balancer. So java -jar load balancer. As you can see, the load balancer is up. Okay, so let's make a curl request to the load balancer. So curl http, the load balancer IP address is this one. So the load balancer is accepting request as port 8081. Okay, so let's make request to the endpoint hello on the load balancer. Okay, as you know, the load balancer is not exposing any endpoint at endpoint hello, because load balancer is basically a layer 4. It has no information about what is the endpoint that is being used at the layer 7. Okay, so it will simply accept the request and pass it to the backend server. So as you can see, now the response is from 54.188.156.42, which is the IP address of the first one. Okay, so as you can see, the last to 156.42. So as I told you, 156.42 is the first one. Okay, this one, and let's see the second one. The second one is 197.100. Okay, so let's make another request and let's see whether it is going to the same host or the another one. As you can see, it is from the other host. Okay, 197.100. Okay, as you can see, the second one was 197.100. Okay, so as you can see, the load balancer is actually now working. So we are making requests to load balancer one by one, and load balancer is picking the first host in one go, and the second request is going to the second host. So basically a round robin algorithm is taking place at the load balancer. And as you can see, the client information is also shown here. Okay, the first request was from this host. Okay, this host is basically a my Mac, as you shown in the starting of the video. Okay, where I hosted the web service on my local machine. So even if we make multiple times requests, so first time it will go to 156.42, and the next time it will go to the 101. So it will again do a round robin. So one request will never go to, so two requests will never go to same request consecutively. It will go like one by one. However, there is a term called IP affinity, okay, which we'll talk like in some future videos. But yeah, the purpose of load balancer is now complete, and load balancer is now accepting request from client and passing it to the servers and backend servers, and whatever the response from backend server it is coming, it is just passing it to the client. This is what in this video. I hope this video was useful and valuable to you. Thanks. Bye.